All right, in this video, we're going to look at more advanced trig equations. This time we're going to use the calculator. I'm going to show you two different ways you can use the calculator to solve a trig equation that can't be done just by using special angles and special right triangles. And we'll start with this quadratic trig equation here. Secant squared of 3x plus 5, secant 3x equals 6. So let me zoom in here. The first thing let's point out here is that we have to do algebra first, right? It's a quadratic. So let's just kind of, let's let our S be, or our secant be called something else like S. So, so again, this is just to kind of remind you that first we are doing algebra. Okay. So we subtract 6 to get this to be S squared plus 5 S minus 6 is equal to 0. And this factors. Okay, and I believe that factors to x plus 6, x minus 1. I think that's right. Okay, so that tells me that s is equal to negative 6. And here this tells me s is equal to 1. And we remember, or we remind ourselves that s was really just a stand-in for secant of 3x. So this means secant of 3x is equal to negative 6. And this tells me that secant of 3x is equal to 1. Okay, so what you might do, what people often do is because we're more familiar with the original trig functions, sine, cosine, and tangent, you might just turn these equations into their reciprocal versions. So for instance, secant of 3x equals negative 6. Whatever the solutions are to that equation must be the same as the solutions to this equation. Cosine of 3x is equal to negative 6. Equal to negative 1/6. In other words, I just took the reciprocal of both sides of that equation there and made it look like this. And similarly, for the other one, I could say cosine of 3x is equal to the reciprocal of 1 is 1. Okay, so basically this is going to produce two families of solutions here. So let's just use a graphing calculator, and I'll use Desmos here. So again, what we're going to see up here is our solutions for x. So x equals, and I go up and I have my graphs here. I've got cosine of 3x and negative 1/6. Okay, so so notice, we're looking for intersection points. I see an intersection point here, right? It's like it's this cosine graph on its way down, on where it's decreasing. And then I see another one here on its way up where it's increasing. And then I see yet another one on its way down. So basically these are, what I've indicated here, the two intersections where the cosine's on its way down, those essentially belong to the same family of solutions. Okay, so in order to describe all the solutions, we need to find one. So that looks like 0.579. So I'm going to write that down here. 0.579. And now I know that I actually just need to add 2 pi over 3, or multiples of 2 pi over 3. So you might ask, how did I know to do that? Right? How did I know that I had to add 2 pi over 3? Because the period of this graph here of cosine of 3x is 2 pi over 3. And so if that there is a solution, and another one that corresponds with that is over here, if you look at the graph, that is one full period of this graph. So that distance must be the length of a period. And that's clearly 2 pi over 3. So this plus this is 2 pi, this plus 2 pi over 3 will give you that, plus 2 pi over 3 will give you the next one. So multiples of 2 pi over 3. The other family of solutions look like they're the ones where the cosine graph is increasing. So like here, here, right? So we need only describe one of them. I'm going to describe this one here, or I'm going to start with this one and then add multiples of 2 pi over 3. So negative 0.579. Okay, so I've got negative 0.579 plus multiples of 2 pi over 3. Okay, those are basically the two families from that in one equation. And then over here, cosine of 3x equals 1. Again, we'll just change this to a 1 and find intersection points. And we see there's 1 at 0, and they're spaced, as we would predict, 2 pi over 3 radians apart, because that's one cycle, and the period is 2 pi over 3. So I'm just going to write my answer as x equals, you can say 0, but if you can just start with, it's multiples of 2 pi over 3. All this being n being an integer. So those are my solutions. Okay, so that was using a graphing calculator. I mean, you basically could have used a graphing calculator to begin with without doing the factoring at all. Okay, but I do want to do a little bit of the factoring with you, mainly because if so this would be fine if you have a graphing calculator. This way is completely legitimate. Some teachers, some pre-calc teachers may give you a quiz on this type of thing, but they don't give you a graphing calculator. They give you a scientific one. And a scientific calculator can do inverse trig, but it can't graph anything. So I'm going to show you how you would solve this equation if you only had the buttons using inverse trig. So the factoring would be the same. Let's start with where we ended here. So basically, we want to deal with solving cosine of 3x equals negative a sixth. And we want to deal with solving cosine of 3x is equal to 1. Okay, so let's deal with the easy one. First, cosine of 3x equals 1. Remember, the cosine is the x-coordinate of a point on the unit circle. So, you could do the cos inverse button, and you'll get that 3x is equal to 0. But you could also just look at your unit circle, right? So when the x-coordinate is a 1, the angle is clearly 0. So 3x is clearly equal to 0 plus multiples of 2 pi. And sorry, I jumped ahead of myself, is equal to 0 plus multiples of 2 pi. And then dividing everything by 3 will give you the answers. So 0 over 3 is 0. You don't need to really write that if you don't want to. Okay, but just using using the unit circle here, right? Because clearly our angle here is it's just if theta clearly equals is equal to 0 here, right? So that gives all these answers, and clearly that matches the pink that we see up there. Cosine of 3x equals negative a sixth. And in order to do this, let's remember again, cosine is the x-coordinate of a point on the unit circle. So negative a sixth, let's just say that's roughly like here. I know it's not probably that to scale, but an x-coordinate of negative a sixth, that'll it's somewhere over here, and that'll get the job done. Okay, so we want this angle here. We want this angle here. Let's call that theta, like theta 1. Okay, that's one angle. The other angle we can call this angle theta 2. Now, obviously, any angle coterminal with each of those is going to also be an answer. But I might as well. There's a nice symmetry in this diagram. So if we can find theta 1 and theta 2, then we just add multiples of 2 pi to each of those to get all the answers. So let's hone in on this here. So if this is the x-coordinate of negative a sixth, that must mean that this side right here I can label negative a sixth, right? I'm in the unit circle, so that's 1. So if I want this angle, right, if I want this angle theta 1, what you can do is you can use the inverse trig button. Okay, so your calculator, theta 1 is just going to be cosine inverse of negative a sixth. All right. So let's go see what that is. So down here, I'll just use this cos inverse of negative 1/6. I get 1.738. Okay, so this is about equal to negative 1.738. All right. Now look, by symmetry, that must mean that theta 2 is wait, something was wrong there. Sorry, that shouldn't have been negative. It's not negative. Sorry, it's not negative. But theta 2 is negative, right? Clearly, theta 1 is a positive angle, so it's 1.738 radians. And theta 2 by symmetry is negative 1.738. Okay, so that would give what 3x is equal to over here. And therefore x would just be that divided by 3. So let's write our two families of solutions over here. So I've got theta 1 and theta 2 by using the cos inverse button. And so I've got that this is 1.738 and then dividing by 3. So again, plus 2 pi n dividing by 3. This will give my first family 1.738 divided by 3. I'm just going to take this and divide it by 3. You'll get 0.579. Okay, so this is 0.579 plus 2 pi over 3n. And then, of course, the other solution would come from the fact that 3x, right, theta 2 was our other angle there, negative 1.738. So negative 1.738 plus multiples of 2 pi. And then dividing everything by 3. Clearly, this is going to be negative 0.579 plus 2 pi over 3. And of course, just write it in a couple times. We need n to be an integer. I probably should have stated just, hopefully it's clear from the example, but really remember my theta 1 over here, I was really solving the equation cosine of theta is negative 1/6, and then indicating that theta is really the stand-in for 3x. But the big idea here is that the cos inverse button will give you an answer. Notice it doesn't give you both answers. So right, when I did cos inverse of negative a sixth, it just gave me this one. I had to use the visual, and I had to use my unit circle and the picture to understand that, well, that gives one answer. The other answer we can see by symmetry is negative 1.738. So when the key thing here is when you're using inverse trig, you're often going to have to look at your diagram or your picture, because cosine, the inverse trig functions are functions, so they're only going to output one answer, right? Even though you're solving an equation, you may want multiple answers. So you're going to have to use a little of the symmetry and your understanding of the unit circle to get the other answers, like we did here. All right, that's the key lesson. So in any case, notice we get the same answers. So you can use a graphing calculator, and you can use a scientific calculator, and either way, you should end up with the same solutions.